which you'll need for this lesson, you should see 3 little buttons. One of them should say tan, T-A-N, and the other two should say COS, which stands for cosine, and the other one should say SIN, and that stands for sine. Okay. Today we're going to be talking about the TAN, the tangent ratio. Okay, so trigonometric ratio is a ratio, obviously. Two sides of a right triangle. So when we knew the angle measures were 30, 60, 90 or 45, 45, 90, we could use the formulas we talked about yesterday. So the formula we're talking about today and on Monday are going to be when they still are right triangles, but they're not a perfect 45, 45, 90 or a perfect 30, 60, 90. So we'll see that the angle measures, one of them is still a right angle, one of them is still 90, but the other two don't match the 45, 45 or the 30, 60, okay? So this is what we use if it's not those two specific. That's why those were called special right triangles, because they had those specific angle measures. So these deal with triangles that don't have those specific angle measures. Does that make sense? It still has the 90, so it's still a right triangle. Okay. So this is how we find the side lengths if we don't have those specific angle measures. Okay, and again, the Pythagorean theorem still applies also. It still applies as well, because it's a right triangle. It just depends on what information they give us in order to be able to tell what we can use to find the missing measures. Because they may give us side lengths and they want angle measures. Or they may give us angle measures and they want side lengths, okay? So when you get to geometry, you can get one problem that tests all those, where you have to figure out by using angle measures what the side lengths are, and then you have to use the Pythagorean theorem to find a missing something or another too. Okay, so really the difference between what we're doing this year and what you do in geometry is we're separating each skill. Right, we're separating them, and then when you get to geometry, you may get one problem that combines all those skills. And we've kind of had problems like that too, where I've been able to test a lot of different skills with one problem. Okay, so this is kind of how geometry tests a lot of different skills with one problem. So again, we've separated all of these lessons, but you in geometry are going to bring them all together. Does that make sense? Yes, no? Okay, so anyways, and this is a lot of information for Friday. Okay, so the tangent ratio is this. The tangent ratio of an acute angle, so an acute angle is what? Less than 90 degrees. Of a right triangle is the ratio of the length of the side opposite of the angle to the length of the side that's adjacent to the angle. So the tangent of an angle equals the side opposite divided by 39, I get 2.05. That's the relationship. That's how much bigger this side is than this side. Okay? Now, if I was to do it here, a cube, right? I would take 39 divided by 80, and I get 0.4875. That's showing the relationship. That's that percent of this, so to speak. Okay, so that's kind of what it's telling you. Now, example 2, super easy, because you get to use your calculator, and it even tells you. Now, everybody's calculator is a little bit different, okay, with how you plug it in, okay. Some calculators you'll have to hit the trig button first and then type in the number. Other calculators you'll type in the number and then hit the trig button. Okay, so for the calculator that I have, I type in the number first. Okay, so they want me to find the tangent of angle 24. What does that mean? That means what would the ratio of the length, and remember the tangent ratio is the opposite over the adjacent. What is the tangent ratio? What would the if I knew those numbers, what would the ratio be of their lengths? So all I have to do, my calculator will do it for me. So I type in 24, and then I hit my tan button. ever seen close, like it would fit with that triangle? Yeah. Now from there, we could find a lot of different things. We could find the area of the triangle by using base times height divided by 2.